I'm Acacia.
And I'm Elizabeth.
And this is our vlog.
Alright guys, so our freaking chemistry teacher gave us a end of the year project.
It's over nuclear chemistry, which makes it worse because we barely know anything about it.
Okay, so, but we know enough, I guess. Nuclear chemistry is the chemistry of the nucleus, and if you know anything about an atom, it contains protons, neutrons, and electrons. Well, the protons and the neutrons are in the nucleus, so they're involved in all the processes of nuclear chemistry. The first part of nuclear chemistry that you should know is that it emits radiation. And radiation is the emission or propagation of energy in the form of rays or waves. And there's three different types of radiation.
Okay, so the three types of radiation are alpha, beta, and gamma. The alpha and beta are the short ranges, and then
gamma radiation has a long range, and an alpha and beta, they are like the daily occurring radiation. They happen when bricks rub together in a stone wall and it deteriorates, or when fruit decays, stuff like that. It's normal. It's not deadly. Gamma radiation is deadly.
Okay, so alpha is just pretty much a new element, but the mass will change. For beta, it's the mass stays the same, but it's a new element. And then gamma, the mass stays the same and it's the same element.
All it does is give off energy. It creates energy.
Yeah, the only thing giving off is energy.
Okay, this is alpha decay. This is what the balanced nuclear equation looks like. It changes the element and it changes the mass completely because that's what it involves. Okay, the next one is beta decay. The mass stays the same in this one, and you create a new element, or it yields to a new element. This is what the balanced nuclear equation would look like. You're given an element, you end with a different one. Your overall charge is -1. Okay, the next part of nuclear chemistry is half-life. Half-life is the amount of time it takes a radioactive isotope to decrease by half. It has an equation, and I'm going to explain that right now. Mass final equals mass initial, so the first mass your isotope started off with, times 1/2 raised to the number of half-lives. And to find the number of half-lives, if you need to, it'd be total time that your isotope had divided by the half-life times. Okay, this is a half-life word problem, and this one it asks for your final mass and your number of half-lives. This is where you'd use the formula. Alright, so on top of everything else, there's also fission and fusion. They are the processes that occur when the nucleus is unstable, which is radiation. That's when the nucleus is unstable. So, fission is when one big nucleus splits apart to make two nuclei. And then fusion is when two nuclei come together to make one big nucleus. Fusion normally occurs in the sun, like whenever fruits decay and all this other stuff. Or there's fission, and fission constantly creates energy.
Okay, so cold fusion we did not learn about, so we had to look it up on our own. Our camera's falling. Okay.
And we're super tired.
Very tired. So it's cold fusion? Because I don't know what it is. We literally just looked
cold
it up.
fusion, it's the same theory of fusion, or not the theory, but the same law of fusion. And it just has a hypothetical twist on it. So it's a hypothetical method for achieving nuclear fusion, which is what I described to you, at low temperatures, such as room temperatures, so in a room like ours.
I still don't get anything.
Alright, so in the real world, nuclear chemistry is used for a lot of different things. Most known is warfare, nuclear warfare.
It's like the race of arms between us and Russia and China and everyone else. But mainly between us and Russia right now. But that would be like one implication to the robot. Another would be radiology, like in the medical field, medicine.
Or submarines.
And submarines. In the submarines, they use radiation to be able to be undetected by the people they might be watching or stuff like that, so enemies can't see them when they're in combat.
Fun fact.
Oh yeah.
Oh yeah.
Fun fact.
Women aren't allowed in submarines.
Well, they weren't up until like a year ago. Some stupid excuse.
Yeah. Okay, so that's the end of our vlog. We hope you at least learned something that we actually kind of knew.
Yeah. This, I know it was boring. Bear with us. We didn't want to do it either. We're both crying.
So, thanks. Now we get to go to sleep. Bye, guys.